All right, let's start. Let's talk about diagrams. We'll talk about all sorts of diagrams, how to make sense of them, and how to properly document your software. So what this is not about, it's not a full analysis and design course. Hopefully you already had that. So we're not going to talk about root cause analysis, about added value analysis, feasibility studies, and we're not going to talk about the software's business goals. Hopefully these have been flushed out before you started the project. Now, it's also not a demo of modeling tools, although I will give you some advice. It's not a detailed explanation of symbology either. What it is about is which diagrams serve which purpose, how to use them correctly when you design your software initially, not when you are done coding and then you want to document what you did. I'll show you how to tie diagrams together, so how to make sense of the entire process, and I'll show you some real-world examples. So the purpose of this would be to create comprehensive documentation, not for the sake of having one, but to truly guide your development efforts. Myself, I'm Filina. I'm a project rescue expert, developer, trainer, speaker. I come from Montreal. Montreal is the birthplace of the blue elephants, also of this one. And it's also where misunderstood polar bears just want to cuddle. Yes, I mentioned the blue elephants. I just did. Yeah, that was the original one. Yeah. You can touch it, it's different. It has a different texture. So why do people not create diagrams? I'm really glad this talk is not being recorded, so I can be a little more silly. So why do people not create diagrams? It's often because they don't know where to begin. There's so many to choose from. People are a bit lost. People consider it boring. I find it really exciting. But I'm special. Of course, one of them is pretty legitimate. They do get out of date, because as you start coding, things change and you have to keep up with it. Also, often nobody reads them. And nobody reads them often because there's just too much signal-to-noise ratio, too much noise. Like somebody once gave me 60 pages of documentation on something we were going to build, and I just looked at it, and it was just paragraphs of text. I'm not going to read that. I just put it straight to the recycling bin. And I'm a very direct person, too. So I just put it there because it's nonsense. It's not useful. Obviously, nobody's going to read that documentation, so there's no purpose in writing something that is tedious to read. What you want is something very short, sweet to the point, and make sure that it's useful. And that brings me to, there's no point. A lot of people, they think that's, why would I waste any time writing this documentation? It serves no purpose. And people often want to be lean and mean. They say we're agile. But being agile doesn't mean skipping everything that can be skipped, or anything that's not related to code is unnecessary. That's not what agile means. A lot of people confuse that. So if you skip the documentation when you are initially designing your software, what's going to happen, you're going to lose productivity and quality, because you're going to go really fast in just a random direction. So that's the point of the documentation, is to give you the direction. And diagrams is one of the best communication methods, especially when you have remote teams or people of different levels or different technical backgrounds. I use flowcharts and ERDs, for example, to clarify requirements with non-technical people. I show them diagrams, and they grab a pencil, and they start changing things around because they understand it. You just need to explain a little bit, and you can get those people to contribute and provide something useful to you. So, and it's not always boring. I mean, you can make jokes with it. You get a software update. Are there any bugs? No, but okay, do you have some spare time? Usually no. So we'll postpone it until next week. Otherwise, we update, but it's usually next week. I've had updates for next week in the last year or something for my operating system, which might not be a good thing, but yeah. So the real problem is that people don't necessarily understand the diagrams, how they fit into their process. They serve no purpose. They're not very helpful because they're not documenting what they should be documenting. People often mistake diagrams for the waterfall model, which it is not. And people often use inadequate tools. Either they're afraid to pay for something that's like professional software, or the wrong people are choosing the software that you use for modeling. And that makes it a pain to use, and therefore you just don't want to use it. So let's jump into the meat of it. Here's a real life example. For a conference management software, we'll build a call for papers system. So as an organizer of Confu, I built all of the tooling, so I have an insight into that. So here is a use case. The use case is the scope. Think of it just as a bunch of features that you want in the system, and you can get a nice overview of that. So you need to define your actors. We have 3 actors here. We have the speaker, we have the attendee, and we have the organizer. Actors can also be external systems. It doesn't have to be actual people. And the speaker, for example, will submit the proposal, will edit the proposal. The attendee can then vote on that proposal. And the organizer, based on the votes, will select some of them, select what will go onto the schedule. And when they select, the speaker will get then notified of that selection to say, hey, you got accepted, or maybe you didn't get accepted. So they'll get an email or something. Although at this point, we don't have to define exactly what that is. And the attendee would also, when the organizer does finish selecting the proposals, will be able to create a list of sessions and speakers to post on the website. And that can be done automatically. It just pushes it to the website, and then the attendees can go and view them. So you just put the big cases. This is just the happy flow, which means that you don't worry about the little exceptions, because then you'll get into a massive, a whole bunch of scenarios that you don't necessarily need to worry about at this point. And this is something that the product owner will probably do, or at least the product owner will discuss with the person in charge of this, and that person will document those features. So from the use cases, notice the actors. We have the speaker, the attendee, and the organizer. From there, we can move directly onto the data flow diagram. And hopefully you can all see that. Speaker on one side, attendee, organizer. So we just copied those actors as external entities for this data flow diagram. This is a context diagram. We don't go into the details. The entire system is one box, and we just want to see, what flows in and out of that system to the different actors. So the speaker, would submit the proposal, or rather will get a proposal form and then submit a proposal, things like that. So all the cases that you've seen have been now translated into actual data, the data that flows in and out. So you can understand, in which direction it goes. And that's very useful because if you look at those outputs, what they tell you is that you will probably need to design some sort of an interface for that. So you will need a screen for each one of those outputs. So you will need like a speaker preview, a proposal preview, and session preview. So you will have stuff going to the attendee. So the attendee, when they log into the system, or maybe they don't need to log in, they go to the application, and they'll be able to see all of those lists, right? And they'll be able to submit a vote. Now, the vote is an input. So that will be probably some sort of form, or maybe an API call through a button or something. But you'll be able to submit some data to the system. So it will probably be a post also. So it already gives you some information. So from that, from this simple thing that probably takes you 10 minutes to design, you already have a lot of valuable information. Because once you know what the outputs are, you can already go and see the person who's in charge of designing the UIs and tell them, well, we're going to need this and this and that. Here's a list. You can already start working on that. So you haven't even finished designing everything, but you already know what the outputs will be. And based on what they propose, you will then know also what kind of data you need to store. And I'll show you later how the mockups tie into detailing what data you need, and then into the database schema. But from here, we already know a lot of things. We can count the inputs and outputs. So there's a total of 8 lines around, right? 2 there, 2 at the bottom, 1 here, 3 at the top. So that's 8. And that's important to remember, because on the next one, what we do, we drill down and we split that one box of the system into 4 sub-processes, right? So these are the major processes. We have number 1, which is submit proposal. 2 vote on proposal, 3 select sessions, so that's something the organizer does, and 4 view sessions, so that's something the attendee gets. And you have the same external entities, and all the inputs and outputs that go from the processes to those external entities, those 3 people, there's still 8 inputs and outputs, and it's all the same data. What changes is that you now split it into more parts, and then you can see internally how it works, right? You can have different databases. Maybe they go through other processes inside. So now we can take one of them and we can explode it further. And it's up to you how far you can explode, although there is a limit how far you can explode it anyway. But you can explode it further if you want. Let's take number 2, vote on proposal, right? So what we have is a person sees a list, the attendee sees all the proposals that were submitted by speakers. They will vote on them, and it will all go to the database. All right? These are all of our outputs. See, still 8 of them. So we explode number 2, and now we get 2.1 and 2.2. We have one process for generating a list of proposals. So we'll get all the rated proposals from the event database, and then we'll send a list to the attendee. The attendee will then vote. That will go into the 2.2, vote on proposal. It will validate the vote, because you might have some rules that will make it being rejected. And then the validated vote goes into event database. And notice all of those processes, you don't know exactly how they work. You just know that they're there. They're still black boxes, and it's up to the developers to implement them. Now, this one you cannot explode further, because you see there's only one line going in and out. So that's pretty much like a function when you think about it. And some common mistakes that people make when they design those data flow diagrams, that's why they're so important. They're probably one of the most important things that you will design for your application, because it can show you inconsistencies. It can show you mistakes that you have in your thinking. For example, sometimes data is not stored. So something goes in, and there's no email being sent, no data, no file created. Nothing is being stored, so you just kind of lose it. A black hole is when data goes in and nothing goes out. All right, so it just sucks data in and nothing goes out. If you see something like that, it means you have a problem. A gray hole is a bit more tricky. Data is still going in, but what goes out is inconsistent with what goes in. For example, you want to process a credit card transaction. You gather a bunch of data. You gather the credit card number, the expiry date, the CVV, but you forgot to ask for the cardholder's name. If you don't have the cardholder's name, some systems will reject it. So you might not be able to process. You cannot have a process payment going out if you didn't have the cardholder's name coming in. So you did have data, but that data is not sufficient to produce the output that you're expecting to have. So this is a gray hole. These are much trickier to spot, but if you take enough time to reread what you designed, then you'll be fine. And then we have spontaneous generation. It's also called a miracle, and it's an actual technical term. It's called a miracle. Miracle is when nothing goes in, but somehow data comes out. Just spontaneous generation, yes. So that's another problem you may have. So you might think, oh, well, I have all of this data that I need to store, or that I need for some other process, but I don't have that data. I have to collect it, therefore I need some sort of screen, some sort of form to collect that from my user, get that data into the application. So you can spot all of these problems right away, and you can address them before you go implementing and realizing, oh, I'm missing a screen. Right, and then you can take those processes. If you want to, you can go further and create flowcharts. Although you don't necessarily have to. I often don't create flowcharts if the people I'm dealing with are sufficiently advanced. So if I'm dealing with senior developers, I usually don't bother, because I know they can figure it out, unless I know that there's some logic in there that's very important, but I can always just make a quick note. But usually, yeah, they're fine with that. If you're dealing with more like junior, intermediate developers, flowcharts can be helpful. Just depends. You don't have to necessarily document all the processes this way. It can be overkill, And that's when people say, well, documentation is not necessarily useful, or maybe because you drill down too much. So in case you need one, here's how it goes. You have, this is the voting on proposals. You have the terminators, you have the start and ends, and then the attendee submits the vote, and then we check whether the call for papers is still open, because they may still have access to the form, but the call for papers is closed. So if it's still open, then you check whether that person is a speaker. And it's up to you to decide whether you want to allow speakers to vote for themselves. But in case your business rules dictate that they're not allowed to vote for themselves, then it will display an error. Otherwise, it will store the valid vote and send a confirmation to the screen. All right. So all of the, and this is pretty simple symbology. If you go with physical process charts, then you get into more complicated symbols, but for now, this is going to do fine. So here's our input and output that we saw earlier. They are denoted by those parallelograms. Is that what they're called in English too? Yeah. Right, so let's go back to the DFD. Now we're going to talk about how to create mockups. So I mentioned that everything that goes from a process into an external entity is going to be some sort of screen. So you grab that proposals preview and you design a mockup. Very, very simple. Don't go into complex designs. Make it simple and throwable, because what is important here is not even the layout. I mean, it looks nice. It helps validate things with stakeholders. But for the developers, layout is not as important as the data they will see on it. If they see, for example, it shows like a picture of the speaker, so they will need to upload the speaker's picture. So it gives them insight into what kind of data they will need to gather. The number of votes underneath is something, let's say you use an API, well, you're going to return a number of votes for every talk. So it gives idea about the data that you need to store or extract for that particular screen. For example, there's a list of sponsors, so you also have to consider that. Right, and once you have an idea about the data that you have to deal with, then you can go and design the schema of your database. And it's called the ER diagram, Entity Relationship Diagram. And yeah, it basically just documents your database. You start with just the names and relations, which would eventually correspond to actual physical tables. So you have an event that can have multiple sessions. A user can submit multiple sessions. They can vote on, different users can cast vote on different sessions. So you have these relationships there. So you have like a one-to-many for event sessions. So an event can have many sessions. And just continue like that. Then you can add primary keys with the foreign keys. Then you have the concept of identifying and non-identifying relationships. If it's too complex, just draw solid lines everywhere. But otherwise, it's useful to know whether you can, for example, the identifying relationship means that the vote needs both parents to be able to uniquely identify it, because the session ID, user ID will be a composite key. So it's just a little extra info for you to deal with, to be able to make decisions. And then you go and fill in the fields there. You have the event name, when the call for paper starts, when it ends. Now this is something that can become outdated pretty quickly, right? That's something people struggle with. So start with this, and if you need to make changes, if you make any changes to the schema, but you don't want to bother, for whatever reason, updating every single field in there, at least if you can add the extra entities and proper relationships, just maintain that. That will be helpful. Of course, it's better if you can put the effort to keep this up to date, but at least having the relationships is useful. Because then it's much easier than to go and comb through a live database. It's easier to just go here, especially when the software begins to age and you get into legacy, then those diagrams become extremely helpful because nobody is around to answer your questions. And if your foreign keys get corrupted or something, then you still have that to know how it's supposed to work. And then you have very simple Behat or other BDD tests. So you can go and start. This is actually documentation. You're starting to get really close to the code, but it is still documentation in the sense that you can confirm those scenarios with the product owner. So here we have, when I send a post request to log in with an empty body, then the response code should be 400. And then you can send user password, and then it's going to validate. So you're going to have all of these scenarios and edge cases, which you can confirm with the product owner because they can read it. It's pretty straightforward. I mean, it can get a bit tricky with the status codes, but otherwise, you can have other tests where you can say, well, the body should contain this and that. So they can gauge what the output is. And the useful thing about it is that you as a developer then go and implement things, and these tests will actually run and will tell you whether your controller does what it's supposed to do. And the other cool thing, before you even start developing, once you've written this, you can hand it to the front-end developer, and they can start, like, let's say you're building this API, you hand this documentation to the front-end developer, they already know how to implement the front-end. They know what to expect from the API. They can start building around it. So they just grab that JSON from the body, and they just mock it, and they can start building a functioning interface. And when you're done and they're done, things plug together nicely. There's no period where you need to adapt. So, like often when people don't use that approach, they end up with a mismatch between what the front end expects and what the API provides. With this, there's no ambiguity because your tests pass and they grab the information straight from here. So everything will work from the first try. And so the front end work can be done simultaneously with the back end work, and that's how that's how you really increase the productivity on your project. Source comments are also very useful. You can have simple and short explanations in line. You can have longer doc blocks on top of functions or classes. I usually document the why more than the what, because the code is supposed to be clear enough for me to know what it does. What I want to do is, what I want to know is why this has been written, because another developer might come and say, this code is crap. Why is it doing this? There's no reason for this. Well, you have to explain the reason so that they don't take things out. Maybe they can refactor it, but at least they won't lose the why. So they would be mindful of the constraints for that code. So, for example, when I used to do client work, when clients would ask me for a requirement change, often in an email, I would just add a comment in the code block explaining what the client asks. So I would take a part of the email and would just paste it into the comment. That's what the client asked. It might seem weird, but this is what the requirement was, and that's why the rest of this code makes sense. Always comment when it's fresh, not later on. Just you finish the function, document it right away. If you have big functions with lots of comments, then it's probably useful to start splitting them, because if you end up with, especially if you have a lot of inline comments on top of blocks of code, well, maybe each of these blocks should be its own function. Think about it. And of course, better naming of things, functions and variables, it's always better than comments. If it reads like English, then you've succeeded. It takes more effort to write something that's longer, but think that you would read it more often than you would write it. You write it once, you're going to read it forever. Like yourself, your other developers, people will keep reading it over and over. So having something that's a variable list, for each item in list. Okay, for each list as item. So I've been doing other languages for a while. Instead of lists and items, you can use a list of proposals or just proposal instead of item. Use something that's meaningful in this context. Because people think, well, of course, it's easy to understand within that context. but people, like while you write the code, it makes sense. But when you get back to it a year later, it doesn't make sense anymore. The context is a bit lost. So write something that's easy to read. Like you read any line in your function without reading the entire function, you should be able to understand what this line does. That's what you should aim for. And that's also what I consider good documentation. Basically, your code documents itself by being easy to read. And then you have to put it all together. And this brings us back to high school essay writing. I think it's good to refresh the memory and make these classes useful again. So the documentation, make it accessible. Don't put it somewhere else. Don't hide it in some other application or another repository. Preferably put it into the same repository as the code. So on the same level as the code, just have a docs folder, put everything there. That's the best way. Then when somebody puts the repo, they have access to everything. Then you define the chapters. Let's say you'll start with the scope, then you'll have all the database stuff, then you have processes, mockups, scenarios, and then you start filling it. Write the topics in bullet point, then add the diagrams, then write some a short paragraph maybe under each bullet to explain things if you have to, if the diagrams are not self-explanatory. Then move topics and chapters around, fill in with details. Pretty straightforward. Now, how much documentation should you write? That's a question people ask me. Well, it really depends. And I'm going to use Grandma's recipe as the basis of comparison. Not that there's anything wrong with it. It's just not something that you would think would require a lot of documentation in any case. So that the application complexity. So the more complex the application, the more details you might have to put in there. So you might have more docs. Security requirements. If there is a high security requirement, for example, the IFS fingerprints database, that's something in the USA. That database needs a lot of security. Therefore, you would need to write more documentation so that people don't accidentally do something in the application that will expose something, expose data, to avoid any vulnerabilities. So you need to say, well, at all point, at every time, you need to authorize, those requests with this token, things like that. You need to document as much as possible. Also, financial impact. If you use Forex currency trading or something, there's a financial impact, the stock market, things like that. A tiny little mistake in the logic can cause your entire business to collapse within 24 hours, like it happens. Forgot the name of the company. So some developer, made a deployment with a tiny mistake there, and they lost so much money on each transaction that within 24 hours, they lost $600 billion or something. Anyway, they bankrupted. So yeah, more docs. Some documentation would have been nice to make sure, also more unit tests. Not just docs. Docs are nice if people read them, right? Team size, if it's yourself versus 20 devs. Although I still debate that it's not like an absolute. Like you can be by yourself. Like I write even pet projects, I document them quite thoroughly because I just enjoy doing it. I know I'm crazy. I enjoy writing documentation. But the thing is, if you have 20 devs, so of course documentation is useful, otherwise everybody will be asking you questions all the time. But sometimes yourself, like in the future, is like another developer. So you might forget things. So documenting decisions, documenting the logic can be very useful. It's a good reference to have. Because you will forget. You will forget because you might be working on 5 projects in between, and then you go back to it, you forgot the context, and you will need to consult some documentation. Team proximity, if you're in the same office, it's obviously easier to ask questions. If people are remote, especially not remote as in distance, but remote as in time zones. I know that if you are 7 hours away from somebody, then you only have 1 hour overlap in a day, and that leaves very little time to answer questions. So people can get blocked for a very long time. So by the time I wake up, somebody in Romania already finished working. And they had a question and they couldn't get an answer and they couldn't make progress on something all day. So it's good to have concise documentation for remote teams. Also, developer level. So some developers can fill in the blanks by reading the top level diagrams. Juniors might not be able to understand exactly what you want of them, so they often need more precise instructions, better tasks. Like, don't give them a big chunk and say figure it all out. It's a bit too much for them. So just cut things into smaller pieces that they can manage until they get better, and you can trust them with fewer docs. And also, what makes good documentation, or rather, what are the advantages of the good documentation? It makes your software easier to build and to maintain. Because you're going in the right direction, you're not making mistakes. You don't realize after coding half of your project that your architecture is completely wrong because you didn't consider this little thing that just came up, because nobody had any diagrams to validate that your architecture is sound. And so you almost finish maybe the project, and then you realize, well, it's not going to, support for multi-tenancy suddenly came up, and oh, well, we have to change everything now. And so you have to refactor, perhaps even rewrite the whole thing after you finished. It makes your team more effective because everything is clear. You also can cut tasks more easily because you know where this responsibility ends, this one starts, because the processes are clearly defined on your diagrams, so you don't step on each other's toes all the time. And you can discover new scenarios or omissions before implementation. So as I said, with those black holes and all that, so you can spot omissions and you can address them before you start writing a single line of code. And it doesn't take as much time as you think. It looks tedious, but in one day you can complete all of those diagrams if you have a clear idea of where you're going. Most of the time you'll be spending clarifying requirements with the product owner, which you will have to do anyway, but at least now you're doing it in one day instead of doing it over the course of the project. And if they go on vacation, you don't get answers and everybody stalls. There's another type of documentation that's less conventional. They're called mind maps, and I use them to brainstorm. I use them to design my slides. So this is pretty meta, right? This is the mind map of this presentation, right? So that's how I designed it, and I've seen people take that to an extreme. Their entire life is a mind map. Like, they have their activities, they have their conferences they're going to go to, their projects they want to try, some ideas, like everything is in the mind map. And they can collapse those branches and they expand, and you see basically their whole life in that mind map. So I don't go to that extreme, but yeah, this is a way I do things for when I design courses or slides. So the takeaways from this talk is, if you haven't, buy a systems analysis and design book or like a UML book. It's very helpful because this just scratches the surface. Once you start designing those diagrams, you're going to have questions about the symbology and how I should represent that. It can get confusing. So maybe a UML book, if you haven't, if you haven't took a course in that, or if you haven't read a book on that, go ahead. Get some professional software. I personally like to use Asta. I'm not affiliated with them in any way, but I think it's a very good software to use. I used it to design the stuff for these slides. Make sure that diagrams are part of the process, not extra work. So by making them clear, making them not bloated, so don't try and drill down too much as you need for the purpose of what you're doing. Otherwise, they get outdated and it's a pain to maintain. The more stuff you write, the more things you have to maintain. And if you have good diagrams, it's going to increase development speed a lot, and it's going to increase the software quality. Because you can't just write down a list of features and follow your gut feeling. I mean, not even for a pet project. So that's it for this talk. I'll take questions. I will tweet the slides right after this talk. and you'll find, I'll also add the link to join in, and that's where you can go and rate it. You can follow me on Twitter. You can follow my blog. On my blog, I write about software. I have poems also about software, which can be fun, so go ahead and read them. Let me know what you think, or send me ideas. All right, I'll take questions now. Yes?
Do you think about the relationship between code and diagrams in the sense that you generate diagrams from the code or the other way around?
All right, so that's a two-part question. You can do both, actually. So from some diagrams, you can generate code. Like there is a Java plugin for that Asta application where you can generate Java code out of the diagrams, which is kind of cool. And you can also generate SQL schema from the ERD, which is helpful. You can do the reverse also, and I think Damien over there, raise your hand, Damien. Yeah, he has a tool that generates diagrams out of the code. So yeah, so you can talk to him about that. Yeah, so I rarely needed to generate diagrams out of code because the way I did it like more conceptually, like higher level to try and understand. And then usually when I refactor, I would start with the code. I will design diagrams based on what the code does. And then from that, I transform it into what I want the code to do. And from that, I can start writing brand new code. So this process called design extraction. But yeah, so at the last stage, so first you extract it, but then you go from basically a clean design into new codes. You completely forget the legacy. So you can, basically you have a new project. Does that help? All right, cool. Any more questions? All right. It's a heavy topic, isn't it? All right, good. Well, thank you very much. Enjoy the rest.